All right, so hello everyone, good evening today. Um, so this class is going to be a brief one, not too much talk. I just want to talk about modules, which is important, for writing production-based infrastructure code. Most likely in a production environment, you won't use just, raw, write-up, just writing resources like that. You will most likely use modules, which signifies segmentation. Oh boy. All right. So now what are modules? Modules are, with modules, you can compartmentalize code, that will be referenced, within the infrastructure. This will help you to be able to add specific features of the code base without, changing a lot of things. You get. So with modules, you can compartmentalize resources, you know, and then with this compartmentalization, you can easily, call out the resources that you need and, within your root module. So your root module is where you have the main, your root main dot cf. You understand? That's what, if you check the last video that we did everything on our root main.tf, called out resources, wrote everything manually. But this one, we are, this time we'll compartmentalize everything into different sub folders, where we'll now call them out in the main folder and then do whatever we need to do there. So now I rewrote the whole code for what we built the last time to better explain modules. It's practically the same thing, but this one is just modules. So this one is talking about modules mainly. So now, within your Terraform project, you specify the resource that you want to create and put them in a folder. Now we know we want to create networking, which is VPC. We know we want to create compute, which is compute, which is, like I said, compute. Then security. So depends on what you want to create. If you want to create Route 53, you list them out in a folder. If you want to create a load balancer, you list them out in its own folder. You want to create what else? What are your sources there? RDS, which is database. You list it right on RDS folder. Now, within this folder, now, it's like, so how will I explain it? Let me put this analogy this way, yeah, for better understanding. Let me put analogy this way. You have been to an estate before. You get. This whole modularization is like estate living. You get. So it's like having that estate. So the different houses in the estate are for different needs for the main house. So you have a very big house at the end of the estate. Then you have a smaller house that is just kitchen. You have another house that is for playground. You have another house that is for, cinema. Or all these things can even be part of the main house. So if you want something like in the kitchen, you walk down to where the kitchen is, get what you need to get, and come back to the main house, basically. Unlike before, the code we wrote before, you are literally building your kitchen inside the main house, which, to be honest, on a production level, you cannot really scale that kind of code, in the long term. So that's why modules models came into play. You get now. If you check here, you will see networking. Inside this networking folder, you will see main.tf, output.tf. You can see, so it has its own main.tf and it has its own output.tf inside here. Inside the main.tf, you define your VPC, which is the VPC that we created the last time. This is the VPC that we created the last time. So here we are using the default VPC as well. Default VPC that is already created in our availability zone. Then we're also using the default subnet as well. So in a situation where you want to, reference, in a situation where you want to write a VPC code, you know what you do, you put it in networking. You can decide not to, you might not even name it networking. Don't mind all this corporate names. You can try to name it what you want. You can name it this EC2. You can name it VPC. It just depends. So the only concept is that every of the resource that you want to create will be grouped in folders. That's just the main concept, nothing more. So this is network. Now output, it has its own output as well. So the output will, it will be for the specific, it will be for the specific networking the specific module that you want to call out. Now, you have created the VPC model. You now want to create the compute. The compute now have its own main.tf, output.tf, and variables.tf. You get, so inside the main.tf, you have the resource that you want to edit. You have your resource, AWS instance, app server. You have your instance type, var. So this one is now referencing the var. Now this var now is getting its values from here instead of the main variables.tf. It's getting it from here. Now, this is actually ideal because there are some scenarios where, please, can somebody also can somebody put on the group that class has started, please? So this is actually very useful for a scenario where, for example, you are referencing a resource. You are referencing a resource from networking inside from security inside compute. You get for a resource inside for security inside compute. You can see now security group ID, there's no default here because it has to go and reference what is inside here. And to do that in the main, don't worry, I'll come to that. You can see it here now. So now there's compute. Let's go step by step. Now there's compute. There's main.tf. This main.tf now shows you this is your instance, AWS instance, AMI, kini. There's the output as well, based on how we did it in the last class. There's the output as well. Then there's variables. These variables now, you can see these three variables are within this compute folder. So they have their default class key, class get as the key name, instance type T2 micro, AMI ID is this. But you can see this other three, which is these other two. Security group ID will need this will need the ID from here, this particular module. You get, this will need the ID from this particular module. So we'll leave it, we're not going to touch it. This subnet ID as well, this will need the ID from the networking module. So you will leave it, you will not touch it. Now, when we come to security module, you can see that security also has its own set of main.tf, You understand? Has its own set of main.tf, has its own outputs, and also has its own variables. Now, it has its own variables. Now, part of the variables, you can see this will need its own VPC. This will need the VPC ID from networking. So it is skipped. Now, security, you can see security here. Inside the security, there's the output. So the output here, security group ID, is already being outputted. So it's out. So it is this output now that will come out from here that this module will catch. That this module will catch and replace here in the root main, and replace here in the root main. So whenever you are referencing a variable in your module that is in another module, that module that you are going to get the variable from, you have to put it as part of the output. So security group ID now, there's an output here. So this output that will project the ID that this compute will catch and replace it in this point. Same for subnet ID. Now, this is asking for subnet ID. This is empty. In your networking, when you're doing output, you output the subnet ID in the networking so that whenever anything is expecting subnet ID to come here and get the value. No, now this is the three of them. If you go to the root, now there's a root main. Inside the root main, what you would now do instead of starting to write resource resource and to do all the resources one by one, you come here and you call out the network, you call out the module itself. Now you can see module networking. This networking is the name. It's not because it is named networking. It's just the name we I'm going to give this module networking. Source modules. Look at it, modules.network. That means you go and get this code here from this point where this networking is. Source module.networking. We'll leave that one aside. Now, security module. Module security. Source modules.security. Now you can see VPC ID is going to reference module.networking.vpc ID. Where are you going to get this VPC ID from? From this output. You can see this output here inside networking. This output VPC ID. So when you're calling it out here, it's going to find the output folder and then find the output folder is named VPC ID and then get the VPC ID to replace here. The reason why reason why VPC ID is here is because in the security, inside security, there's a variable asking for VPC ID, but it's empty. So if you check in security variable, there's a variable for VPC ID, but it's empty. So when it's empty, you have to replace it in the root main. In the root main.tf VPC ID. So that means this VPC ID now that is in this VPC ID that is here inside this point, it will go and get the output of here and replace here in this main.tf. I don't know if it sounds clear enough for understand. So this is VPC ID. Now see module.networking.vpc ID because the VPC ID was in another module. So you have to bring the two of them, summon the two of them out in the root main. The root main is like the dining table where everybody will gather. This one will do his own part, this one will collection gather. So they're not ask, what do you need? Just like as if you're gathering all your children. What do you need? In child A, what do you need from child B? Child B will say, oh, I need his yellow toy. This one will say, okay, take the yellow toy. A will give B, you take it like that. So they're calling all the modules out to the main. You're bringing them outside. then you're fixing it. Now, if you notice, modules come first because it's being referenced. So you have to be careful. If this networking comes last, sometimes Terraform can be very funny. They can start, working on modules from the top to bottom. So if networking is under, and then you now reference model networking here, it may tell you it is not found. It may, it may. I don't know if these newer versions are cleaner, but it used to do like that before. Now, going back to security, you can see backend ports, common tags. Now, all these tags now are part of the configuration. Now, same thing you see in compute. Now, module.compute. Okay, sorry. Module compute. You can see here source is from here. Modules/module/compute. Going to pick this code here. Now, AMI ID is going to pick the variable AMI ID here. Default. Going to pick that here. What else? Instance type, instance key. Now, security group ID, because security group ID is inside, because security group ID is inside the security module, you do now have to reference it. So if you look here now, you see module.security.security group ID. Why? Because security group ID was already listed here as a list. If you check security group ID inside variables, sorry, output, you can see security group ID here. Security group ID. So this was already outputted because it knows, Abira, that you as the architect, you know that you will need it here. So you will need it here at these compute variables. You will need it here. Now you can see that the type is a list of strings, because security groups have a lot of like different strings going on. So you have to put it in a list, not just one string. So that is why when you are referencing it here, you use a square bracket because it's a list of strings. So you put it inside a list of strings. The output that will come out from here is not just one string, it's a list of strings that will come out here. Because each inbound and outbound row has its own, it has its own ID attached to it. So you just have to be, cautious. Then subnet ID, the same thing. Now, the reason why someone is choosing subnet ID is because the subnets is choosing the first subnet, which is this one, 0. So you're going to find the first subnet in the list because the default subnet in US is one, not Virginia. There are like 5 of them. So going to pick one. User data file, the same thing, still using the same user data file as before. Still using the same user data file as before. And variable, main.tf. The same thing, app name, app. So you can see how modules is called out. You can see how modules are called out. Module, compute, Kiniki. Now output, there's output. Output is now this is the output from all of them put together. These 3 modules, when you brought them out, the output itself, where you have the instance ID, public IP, public DNS, private IP, security group IP, BGP IP, subnet ID, key pair name, SSH command. This is the output. This is the just the way you have the root main. This is the root output. This is the provider that you are aware of. The provider that shows that we're working with AWS. This is the README. No, it's not important. Yeah, it's important to show projects, this thing. Then there's the variables. So this is the root variables basically. The root variables. You can still decide if you have a variables inside all this, you can still leave it here. You can still leave this. So yeah, that's just it basically. It's very now see the this thing. Inside your Terraform folder, you have modules. So when you create, you have modules. Then inside these modules, outside these modules, now that's when you now have your root main, your output, your provider. Now inside this module now, you inside this module now, you um you have your different resources. There's a compute, there's networking, the security. You can have RDS, you can have data because database, you can have kitchen, you can have up to 10, in fact, more than as much resources as you like. This whole concept of modularization came because of the need to scale infrastructure faster. Imagine you going to write all those resource, kini, all those things we did the last class. You won't be able to find it on time to scale. Like now, for example, now see this compute now. If I come here, or rather if I go to the variables and I want to change this now from T2 micro to T2 X large, I just come here and edit it rather than going to find it wherever it's buried inside here or going to start digging down. Because sometimes you may even the reason why this is also was also found because sometimes you may be in a position where you may be in a situation where um English has eluded me. You may be in a situation where the variable you are referencing in the root main, the root variable, accounts for you know, multiple mentions throughout your code. So this key name now can be called, you can call this variable key name in different, I'm just using as an example, in different modules. You get so once you edit it in one place, it will now go and start altering the different modules. So which will cause problem. So that's why it's good to compartmentalize it into its own little shell, then call them out here whenever you just need to make any adjustment. So this is the root module. You can have as much of module compute and the rest of them. Also, as with this one now, you can also get marketplace modules as well. You can look for a marketplace module and bring it so that you see how it's referenced. If you don't want to build your own module from scratch, you can reference a marketplace module. Hold on. Okay, copy. Now let's see this. You can see I just pasted something I got from documentation. You can see this is a marketplace module. Now see how different this one is. Let's say you want to create a database and you don't want to start building all the parameter groups and all those things from scratch. What you just do is source. The name is module. Now the source, instead of it to be .modules.here, you reference it directly from the Terraform AWS module /RDS/AWS. This is the library that is going to get the registry for registry modules are. It's going to Terraform AWS modules registry, going to look for RDS and enter AWS. Now the identifier is DemoDB. So this is the identifier go to. All you just need to do is get all the keys that they put and then put your values inside. So DemoDB, MySQL, T3 large, allocated. So just basically what you need to do for yourself. You put it. This is actually easier if you're trying to quickly bootstrap an infrastructure. You get, but if you need tight, tight level security where you can handle everything, the networking and everything you want to do, then you do this. Then you do this. You build it from scratch, basically. So you can see all the setups. These are just very, very. So yeah, so let me delete this library. So, is there any questions so far? This class is going to be quite short. I don't even think I'll stick to 1 hour because I've submitted your capstone already. And please, I need you to do that. We need to do that. We need to do that stage 7. Very important. Try and submit it before the deadline. So yeah, I think let's try this. I didn't run it when I was building it. I don't know if there's any underlying errors. I know I just only did Terraform plan. Now, if you are building this stuff from scratch, let's say you are writing this thing from scratch now. I say writing, what am I even saying? If you are writing modules, you're using your own custom modules, you have to initialize them. So if you have already initialized the Terraform project, then you now change to modules. You have to run Terraform init again to initialize the modules. No, it's not giving me what I want. If I clear this. Now, like I said, you have to initialize. You see, therefore, you have to get Terraform init first to adjust its settings to, include these modules that you have just created. If you did registry modules, you have to still do Terraform init to initialize it, to adjust the settings to be enough to adjust itself basically to accommodate these modules that are created. So you can see initializing the backend, initializing modules. You can see it, initializing modules, then initializing provider plugins to keep on running. I'm wondering why they're just 84 in this class. Surprising. Anyway, when now you see Terraform was successfully initialized. Now, as usual, Terraform plan. Once you do Terraform plan, it will now do instead of doing showing you resource creating, show you module dot compute dot kini creating, module dot this one dot kini, that kind of thing. Doing Terraform plan. As in module dot networking dot data that's now you can see which one is VPC. You can see the subnets now. This is the subnet. So it's going to call out all the subnets. These are all the subnets, the default subnet. But that one we did 0. It's going to select this first one because it's the first one. Remember when I taught arrays in Python and shell? I don't think I'll need to repeat that. So yeah, now do Terraform apply. Let's transport to approve. Set this. Now you can see once I did Terraform apply, it brought out the TS states. Brought out the TS states, but TS is not going to my repo. That's why it's blacked out. Brought out the TS to start taking record of the resources that will be created or not. Now, by ideally, this TS is not supposed to be in my local repo. It's supposed to be in a bucket. Of making these changes. There's someone wants to come and work on this repo again. What they just need to do is just to reference, the Terraform we need and to get the current state from the bucket. I can see reading complete. Decide to create starting. You can see creating. Creation complete. You can see creation complete. I gave me the ID of the newly created security group. After creating. This how it's gonna do. Still creating. Still creating. It's going to tell you still creating after every 10 seconds. Now, one thing with Terraform is that you have to be very, very careful. Sometimes you will think it's still creating per se. Alright, just finished. So you can see now, creation complete after 41 seconds. Apply complete 2 added. Now you can see the instance name, the IP address, the subnets. These are the subnets. These are the subnets involved, the VPC ID. This is it. So let's, as usual, to go down to our infrastructure, refresh. Yeah, see now EC2. Loading instances now. You can see our newly created server. The instance ID is I-04504C5. Yeah, you can see it's correct. So yeah, so yes. We are. So like I said before, modularization involves compartmentalizing your resources into different folders and referencing them in your main. So yeah, it's very simple, it's very, very simple. It's even way more simple and easier to scale than doing just writing resource. But for your task, the current task, I think you will do resource. Then for the capstone project, you will do module. Group them in module. Capstone project is actually really good though. Like, so let me give you people expo. They're still going to work with Dream Vacation app, front end and back end. However, prepare your mind. You're going to write modules for the infrastructure. You're going to do CI/CD. You're going to write shell scripts to perform some server tasks. You are going to write shell scripts. You're going to get a domain, a free domain, create a hosted zone on Route 53. Now, let me, while we're on this call, let me show you, before someone human being will come and tell me, did you teach us in class? So I know now if you want to settle it for me, take it for. But anyways, this is Route 53. Route 53 is for DNS management. Now, what's DNS? DNS is domain name service. So if you want to manage domain, all those things where people will do, oh, let's go and buy a domain name and do kini. Is in Route 53 that is the service for that in AWS. Now you can see hosted zone, just like what it means, is the hosted zone for a domain name service. So for example, if I want to buy a domain, this is my own personal email, this is my own personal domain name. Well, I was trying to build my portfolio. I'm trying to build my portfolio, so I got this for myself. However, I'm being charged $0.5 every month to keep this. So if you are creating a domain name, you're going to be charged $0.5 from AWS. That's like 700 naira or 750 naira. And you have to ensure that you delete it before the end of the month, not the next month you charge it again. This thing you're seeing now is running 750 naira from my account every month. But I'll create a hosted zone. I just left it there, sir. Now you create a hosted zone. If you have a domain name, now part of the tax will involve you creating a domain name. Let's just say my, or rather put your name Peter Vacation. Please go and look for a free domain. No, there are free domains you can get, probably like MZ or YK or TK. Peter Vacations, because the Dream Vacation app dot TK. Just name it this basically. Public hosted zone. Then when you create a hosted zone, I'm not going to create one, but when you create a hosted zone, it will come here and update with the hosted zone name. Now you go to your the place where you bought the domain name from. Now there are some sites which I put in the listing. When you see it, you will know. There's some sites where you can go and get domain name. But if you don't want, if you can't get a free domain name, you can get one that is like $1 or depend. But I would recommend free so you don't have to start burning money. Find a free one. You can now go to the place where you bought your domain name. Inside your hosted zone here, you will see NS, which is name servers. This NS means name servers. You will go and copy these four name servers into the place that you bought the domain name. You will see, first of all, each place that you buy a domain name, they have their default name servers. You go there and you change it to this. Change it to this here. So you go there, change NS, copy this one, go there, paste. That's where the name servers is. You do update name servers. In Namecheap, I know how to do this in Namecheap because I use Namecheap a lot. But Namecheap is not free. Namecheap you can get domain from like $3 above. You can even check it now, sir. Let me check if there are cheap domains you can get. Because I want us to use the free one. But if you can get a domain name, it'll be fine. So this is Namecheap. I use Namecheap a lot, but Namecheap is my idea. Let me just use let me just use uh, let me see what is there for me to buy. When you search to give you the different ones .com, .org, .kini. I feel like .online is also free and it's also cheap as well. It all depends on what you want. I'm just so time to load. So where you copy this there, then you come and do create record. Now this creating record, create an A record. There's A record, there's C name record. Do a record, you leave this. So this is for when you want to create the A record as a subdomain. So you leave this. That means nothing will be before Ezekiel Umesi.online. But if you want to still do it, you can just put capstone or something. Capstone. This one is actually useful when Ezekiel Umesi.online is already pointing to something else. You just want to create a subdomain that will point to this your project. You can just do capstone.this. Now you come here and then you get the IP address of the EC2 instance that you've created. Oh, EC2. Create the IP address of the EC2 instance that you created. Get the IP address of the EC2 instance that you created. Which is the public IP address, which is this. Come here. Then you come here. Add it here. Now, this one. Now, if you want to, this alias here now is if you want to point, this alias simply means you want to point to an AWS resource. So instead of pointing to an IP address, you want to point to an AWS resource. So if you click on the alias on, it will tell you route traffic to. It's going to give you a list of services you can route. So if, for example, now, if I built an application that I have connected to a load balancer, and I want to use my domain name to point to the load balancer, I'll come here and put application and classic load balancer there to fill it out for me. If I put the region, but I didn't create a load balancer, so I won't fill it that. If I created a CloudWatch, if I'm routing it through CloudWatch, I do the same thing as well. It's going to show me the CloudWatch region. If I do it on S3 website, come here to point to the S3 bucket as well, just like that. But since you're not doing to alias, because turning on alias simply means you want to route capstone.ezekielumesi.online to a service on AWS. So the service can be a load balancer which is connected to your application. You get, but if you don't want to point to a service, just want the IP address only, which is your EC2 instance IP address. You just put the IP address here. Now time to leave is 300 seconds. Then routing, there's simple routing. This one, they are weighted routing. This one's a lot of explanations depending on you need to do, but simple routing is the way to go. Then we click on create record. Now, this thing I'm seeing here, this thing I'm doing here, you're doing it in Terraform. Oh. So just take your time, watch the video, understand it. Go and look, go to the documentation, find Route 53 there. Now, what you would do, I'm giving you expo now. What you would do is manually go and create the hosted zone. So when you buy your domain, when you've bought your domain or you've gotten a free domain, manually go and create a hosted zone. Create it manually. Now, once I've created a hosted zone, manually carry all this name NS, all this NS here, copy it on the domain name provider. That's what you do manually. Then what you now do automatically is this thing I just did, creating this domain name and routing. You do everything on your Terraform code. You do it on your Terraform code. And once you click on apply, it will just do this, this routing for you. Then once you destroy, it's going to eliminate this immediately. Now, going back to Namecheap, you can see .com. I think I used to have this .com, but I misplaced it. I didn't pay for it. Okay, yeah, what I had was this dot XYZ. But my current dot online shows that these things are not cheap. I have this dot online. Don't know who went to buy dot blog. There's dot live. So it depends. If you have an extra change to spare, if you had like this one, see this one now is expensive because it's dot AI. They know how how in demand AI startups are, so they put this one here. So you can see this one is two. I think I had this. I'm going to buy this again, sef, and keep for myself. I had this. So it depends on what you want. Let me just some free domain names. Get free domain names. Free domain. You can get this one. Let's just see. I can see this one nice available. .work.gd. You can click. You can use this service and get it 100% free. So yeah, just explore basically. Find the one that is useful for you that you can get it. And find the one that also allows transfer of name servers as well, so that you can transfer these name servers. Because without this, these are the name servers that route. This name server is what links the domain name to the resource, which is on AWS. If you don't put this, it will not do that. It will not. But without this connected there, this capstone.kinikini, it will not reach this IP address. So there's nothing on my server right now. So even if I do capstone, there's nothing on my server. Online. It will not reach, it will not propagate because nothing is installed on my server. It's only Docker that's installed inside there. And Docker is not really anything. So yeah. Um Now part of the task is after you have created your domain name and the rest, you're not going to do SSL. So the SSL, that one you do it manually inside the server. You can also write it as a Terraform code as well. Install setbots. It's very basic. It's just like doing your normal sudo apps install setbot. Setbot now you configure it, and then this thing will have a padlock here that is normally in there's normally in all these websites. So yeah, when you run your domain name with the padlock, which is the SSL, your dream vacation app is supposed to come out. So that's just legit simulating a real world deployment, because that's the real world deployment you do in your project phase. So yeah, any question? I feel like why do I have a strong feeling that Fatima is excited? Fatima and Karen are excited for this project.
Sir, please, I want to ask,
All right.
for the instance type, I always see T, then T3.micro. That's not a problem, right?
No, there's not a problem. It's
For
just an
future.
upgrade. It's just an
Okay.
upgrade.
Yeah, I just want
Before it
to
was
know.
T2, before it was T2, now they have made it T3. But T2 is still available. It's just basic. They're all underlining tech. You see, the underlining infrastructure is still the same. What the T series does is provides you bustable resources. So what are bustable resources? Bustable resources is resources that if the CPU now is, let's say, T2 micro now, I think it's 2 CPU or so. I can't really remember that in offhand. Now, what T series give you, as the engineer, is 40% of your overall CPU initially. So that's what you'll be running. So if your application is running, it gives you 40%. Now, if the traffic increases, it will blow up from 40% to wherever it will land. That blowing up uses what they call AWS, uses what they call credits, CPU credits. Now, if your application is the type that has high CPU utilization, you're going to max out your credits a lot. So that's why you see applications, you run an application when there's high traffic to crash. Because those applications are most likely using T-series infrastructure. Because when it goes up, the CPU credits inside will finish, and then you see that the application is no longer reachable. That's why T series are mostly used for demo and test type of prod. But in production, when you know that you cannot predict the amount of traffic that will hit, you never use T series. You use the R series, which is M series is general purpose. R series is for applications that have high memory consumption. The C series is for applications that have high compute, which is high CPU. You use it. That's another cloud class on its own when you want to go deep inside cloud. But that's being said. So for this project, you're going to use T2 or T3 micro, which is the smallest, to scale. And since you're just building stuff inside Docker and the rest, that one the thing will not spike. So that's if you have high traffic, so it will not spike. So it's just within your plus it's free tier because yeah, it's cost effective. So yeah, basically. So yeah, there's no problem. Any more question? Karen, you came late. Oh. Good evening. Wilfred, good evening, boss. Your assignments, you always bust my head. I'm not even sure if you're a learner,
Sorry.
sir.
Then the last question, since today is the last day to submit, right?
Is it today?
If
It's not.
we, yes, it's 29th. From what I see.
Oh, okay. But nobody has
Yeah.
submitted now.
Uh,
Is it today is the last day, Abby?
yes, from what I can see.
Let me check.
August 29th, due date.
Sir, can you hear me, sir? Sorry.
I can hear you.
Yeah, so I think I read the message and it was saying that those that didn't meet up to the deadline, they would not have the chance for internship. That's like the red flag to it, right? So if you are late, you
August
can still
29th.
like do your stuff
No,
and
if you
submit.
can late, if you're late, you can still submit, definitely. But
Okay.
the chance to be part of the internship will not be there most likely. But if you're late, you can still submit.
So what I
Okay.
wanted to ask, what I wanted to ask is,
Okay.
suppose you have something like 70% done.
Uh,
I can just use
uh,
it.
push it first. Then once you push it, you update it. Can you hear me? Can you hear me, Jose Maria? Push it first. So is there any other question? Your microphone is full. I'm hearing you very, very faintly. Adjust your microphone and speak out. Okay. Yes, gone off.
Is it okay
Um,
now?
yeah, it's okay now.
Okay, I want what sorry, I didn't hear what you said because I was asking, assuming I'm 70% done, I can just submit the link to my
Yeah,
GitHub and then complete.
submit the link and complete. I think
Okay, all right.
Fatima did that thing some time ago. She committed the link. She now messaged me that see, oh, she has not submitted, she has not finished, but she just wants to submit. I said, okay, take your time. When she
All
finished
right.
it,
All right, no
uh
problem.
So just do that.
No problem. Thank you. Yes, sir.
Mm. And so another thing is also thank you for celebrating my birthday on Wednesday. That day I slept. I needed sleep, so I slept. Hi Isaac, good evening. Well, you want to say something? This DevOps part, to be honest, this DevOps part, not the part that you carry clear because if infrastructure issues hold you, you can be on call. And for the past few, I'm telling you, prior to this week that my birthday, I I was on call. Sometimes I was on call till I'll be on call till 2 a.m. because we're solving one issue. There's the particular class I had shortly after the class, I think it was a Friday class. Shortly after that class, I got a call. It was a Friday class. I think class ended by 8:30. Do you know that from that class, I didn't sleep till like 3 a.m. because we are from that class. That's why while we were ending the class, I got a message that oh I should check this thing out, it's critical. I was on that thing till 3 a.m. because every deployment I was pushing was failing. Every deployment I was pushing was failing. Kept on failing, kept on failing, kept on failing, kept on failing, fail till midnight. I was adjusting, tweaking this Terraform, tweaking that. Sometimes with Terraform, not manage. This one is just basic stuff. Sometimes Terraform can the state. Those of you that still use earpiece, me too, I still use earpiece, so it's not a shade. Those of us that still use earpiece, when you're roughing earpiece and put inside your bag or put inside your pocket, once you bring the earpiece out, it will take you a while sometimes to tangle and twist and turn. So that's how your Terraform state, if it's not properly managed, can be. So if that thing is not managed properly, if that thing is not managed properly, your deployment can fail, even if you're right. So I just had to adjust, did a lot of troubleshooting. I had to now deploy it in a small scale because I was trying to deploy a database. I had to do the database, enterprise level database. I had to deploy it in a small scale, which is single easy. Did a lot of troubleshooting, did a lot of testing. Then I now, when that thing showed me available at the end, that's after I had deployed the database, showed me available. The way I slept there, and that day was Friday, breaking Saturday. I slept till like 10 a.m. the next day. So I've been taking a lot of overtime these days. So I just stayed this for my birthday week. I'm going to rest. So I slept. I slept. I slept for like 12 hours, 13 hours. So yeah. So that's just it though. I feel like I want everybody here to get that experience. It's a rewarding experience at the end. Because you get to build your skill, you get to face challenges.
So I want to ask for this for the last assignment, right? I actually
Yeah.
created a new branch and then created a new GitHub action for it. I hope that won't be a problem.
No. Just
Or
submit
we should
the GitHub
update.
action. Submit the GitHub action branch.
Okay.
Thank you, Karen. Thank you very much. Appreciate.
Sorry, I don't get. I should submit
It's
the
create
branch,
a
the
new
Terra.
branch. Create a
Yeah.
new branch, add the Terraform code inside the new branch. Or you can
Okay,
update.
okay.
See, I just want me and my own that I just want to see Terraform as per Terraform
All
folder
right.
with Terraform code. You
Okay,
can
okay. I
update the
did
current
that.
one or you create a new one, basically.
Okay, I created a new branch.
Yeah. So that's just what it is.
For the internship, are you among our mentors?
Hmm, I don't think so. I don't even want to be honest, because I won't lie to you. These 2 hours of teaching took bulk of my time because sometimes I'll be on call, I have to leave call. So I'll just be here, I'll be at the sidelines. Anybody has any question. But I don't think I'll be. I don't know yet. To depends on their location if they are assigned. But let's just see how it goes, basically, because you have to work in a team. You won't need teachers again. You won't need mentors. You are in a team, so you are simulating company work. People will have everyday meetings. People will set time. There's a project manager. People will set time. People have meetings every day. So it's like real world experience. You understand? People have meetings every day. Talk about your progress. You know, talk about people have we assigned a Jira board where you people keep in track your progress, throughout. That kind of stuff. So just think of it as you are building a project for this 1 month. And we have deliverables, deadlines, basically. So yeah, that's how you do it. You work directly with your project manager.
Um,
Project manager too is
am
also good
I
from yeah.
am I LMS? I'm seeing tax 7, but stage 6, I'm still awaiting promotion. I hope if I submit, it won't be an issue. I can see
No.
stage 7 now, but I'm still seeing that I've not been promoted on stage 6. But I can submit on stage 7. I'm talking about the promotion. I've not
Just
been
submit
promoted
first.
on
I'll
stage
reach out
6.
to the product manager. Just submit
Okay,
if you
thank you.
can. But anyways,
Okay, thank you.
yeah, that being said, I feel like there's no other question, yeah. Fatima, Isaac, Jose Maria, Karen, Wilfred, thank you very much for riding the wave so far. Um, do hope that you can submit your tax on time. And if you can't, just try your best and do it this weekend. So yeah. Um, all right, take care of yourself. Thank God it's Friday. Enjoy your weekend. Reach out if you have any issues. Thanks for solving the list submission. Hey, hey. Okay, well, no wahala now. Take care. Good night. Ha 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 ha. Well, I'll meet people too. Good night. Good night. Bruh.